Hello, everyone, and welcome to another episode of the Virtual Ninja Show. My name is Javier Soriano, and today we're going to be talking about a Sentinel topic, of course. And this is a very new one. It's something that we never had in Sentinel before, and it's about federation, data federation in Sentinel Data Lake. And for that, I have my colleague Amy to talk about this feature. Please, Amy, tell us who you are and what you do for Microsoft.
Sure. Thank you, Javier. So my name is Amy Dang. I am a principal product manager for Microsoft Sentinel, specifically working on Data Lake and in this case, data federation. So really happy to be here with you today.
Perfect. Welcome, Amy. So first of all, in a nutshell, what is federation in the context of Sentinel Data Lake, and what is the problem that is meant to solve?
So with data federation, one of the things that we're doing is we're helping with organizations that quite often they might have systems of authority. If you think about HR data, you might think about other systems that are heavily operationalized. Maybe they have a lot of workflows, right, already running on these systems, or they need to be where they are for either regulatory requirements, right? There might be reasons they can't copy that data or move that data from the region that it's in. So in these situations, what's happening is we have customers that want to adopt and onboard to Sentinel Data Lake, but they've got data already sitting in other systems external to the data lake. And in some situations, they want to adopt data lake and actually start ingesting data to data lake, but the issue might be that they have years, right, if not even decades worth of data sitting external. So the question is, how do you bring in that rich context that is sitting outside of your lake into the data lake to enrich those investigations while you're on your adoption journey, right? Or when you're dealing with systems that you just simply can't move or duplicate that data. So with data federation, what we're looking to do is actually meet that data where it is. So when you have those systems that are external, how can we reach out to allow you to still get to that data to enrich the context of your investigation, but not actually move or copy that data? So that's really the issues that we're trying to solve for our customers.
Fantastic. And we released this feature really a few days ago. What exactly did we ship in this public preview? What different systems we can federate with? What is the kind of feature set that we established?
Yeah, so with the first release that we have here, we're going to allow you to federate with Azure Databricks, Azure Data Lake Storage Gen 2, as well as Microsoft Fabric. And one of the nice things about Microsoft Fabric, you've got a bucket and you've got data sitting there, tables that you would like to use. You'll be able to actually federate to that Fabric workspace and to those tables transitively from that Fabric workspace, which is a really nice way during this first step that we're taking to allow you a little bit more, right, than those first sources that we're supporting directly.
Fantastic. So not only we support those ADLS, Azure Databricks, and Fabric, but through Fabric, we can also support additional external data sources, basically.
Exactly.
Fantastic. So let's go right to it. Let's show the audience how this works in real life in the Sentinel portal.
Absolutely. So essentially here, what you can see that we've got an Azure Databricks instance set up. We've got an idea of the schema of this table that is sitting here, and even a little bit of that sample data. So here, what's happening is every time you need to access privileged AI training data, which is critical to the business that we're talking through here as a sample company, right? So it's critical that this data is protected. And so every time you need to access some of these machine learning models or this training data, you need to provide additional verification proof. So this is essentially a Databricks that has that, as well as if you think about how folks use Databricks today, you might be already performing just compute within Databricks to transform that data. So we also have another risk signals log that you can see in this Databricks, and we're actually able to take that inside of Databricks, and maybe we're running something proprietary, something unique for our organization to enrich these logs. So in our case, you can see that not only can I see the verification methods used, but I can even see what they were accessing, why they were accessing, and then something called a session risk level that we're able to actually enrich into this table. So here, how can I get to this information to enrich my investigations would be one of the key things that we wanted to show. So now we're in the Defender portal, and we're going to go ahead and get started. So we'll expand Sentinel, configuration, and data connectors. So within data connectors, you'll see a new area called data federation. And within the data federation, you're going to see a catalog. So these are going to be those available connectors that I mentioned to you. So one of the connectors that I've already set up here is called global fraud, right? So I'm actually going to delete this so I can set it up with you. And we'll go ahead and walk through what the steps look like. So let me put in the details here for you. So here I've given it an instance name. Now with the instance name, you want to be careful to use something that is meaningful. Now the reason for this is once we set up this connection, the tables that will come over from this connector will actually have an underscore with the instance name. And this will allow you not only to quickly identify these tables and where they're coming from, but it's a way to help us ensure that these table names will be unique, right, between different instances. In this case, I've named this global fraud. The next section is all about the service principal that has access. So here we've got an application that was already set up, a service principal already set up here called Fraud SPN. So I've put in that client ID here. Now, you need to have the secret for that service principal in an Azure Key Vault. So I've already got an Azure Key Vault set up. I've placed that URI here, and then a secret name, right, associated to the secret value that I stored there.
And Amy, on that, I guess that service principal, you granted access to that service principal to access the Azure Databricks environment. Is that right?
Exactly. So this service principal is going to have access to the source that you're connecting to in the case of ADLS and in the case of Azure Databricks. Now, in the case of Fabric, it'll look a little different. You actually don't need to use the service principal. There's a different set of steps where you'll be using actually the Sentinel application identity. But for this particular connection, we will need this. So we've already set up all the permissions in our global fraud catalog. So that service principal is ready to go. The last portion that you see on the screen is going to be the actual target destination. So I've got the URL for my Databricks, the catalog name, and the schema name ready to go here. So the next step is it's going through and it's actually enumerating all of the tables that are in Delta format. And in this case, we by default will select all of the tables for you, but you can unselect tables and just select the ones that you want. So in our case, I'm going to select the risk signals and those identity verification logs, and I'll hit next to move forward.
And Amy, could I choose to give access to the service principal only to certain tables? I know that here we can select that in the connector instance creation, but can I just grant access from the service principal to only see certain tables? Is that granularity possible?
So in the case of Databricks, this service principal will need access to read at the catalog level. So we do document these steps for customers, but both for ADLS and for Databricks, you'll notice that they need to have that blob reader for ADLS at the container level, or in this case, you'll need to grant read at the catalog level.
Got it.
So once we've done that, it's just your standard review and connect here, so we can confirm all of the details that we've placed in here, and we can go ahead and hit connect. Now behind the scenes, what it's doing is it's setting up that connection to the Azure Databricks, and it's storing the metadata of the tables that we selected. And that metadata is going to be key for us within Data Lake because we want these tables to look and feel a lot like a native lake table would look and feel. So the things that we're storing are going to be the table name, we're going to be storing the column information, that schema, right, that we saw in the Databricks, so that you can leverage our features like KQL queries in the same way that you would normally do today. All right, so we can see here that our connection has completed successfully. So I'll go ahead and close that. Within Data Federation, you'll also see My Connectors. So when you click on My Connectors, you'll be able to see any connections that have already been set up. So you can see that I've got a global HR data connection that was set up for some HR logs. We've also got the connection that we just set up here. So if you click on that, you can see the two tables that are flowing from this connection. And as we mentioned, you can see that they've got an underscore with the instance name that we created. Now, once we've connected this, a very important thing is visibility to all of the tables that you've connected. So here, of course, you could do that by going through the different connector instances, but that's a little bit of a heavy lift, right? So within Sentinel Data Lake, we already have a table management experience under configuration. When you go to this table management experience after performing connections for data federation, you're going to be able to see that data right alongside those native lake tables. You don't have any separate or special workflow you need to worry about. One of the things you can see at the top here in that ribbon is we've brought forward the federated count for you so you can quickly see I've got 14 tables that have been federated to the lake. I could quickly filter by federated here. If I want to filter by that, I can see all of them. I can also search. So if I use global, for example, which was the suffix for many of my tables, you can see the HR logs that we talked about. You can see that these are flowing from a ADLS Gen 2. If you were to click on this, you'll actually go to that connector instance. You can see the schema for that table. For example, the one that we just set up is here, so we'll just take a quick look at that. So you can see this is coming from the global fraud instance, and you can see the schema of that table. Now, one thing that I'll mention really quickly here is time generated that you see at the bottom here is something that I've added to my sample data, but we don't require you have a specific schema for a federated table. So this is really important to understand because if you don't have the time generated field, you won't actually be able to use the KQL time filter. And I'll show you that in a minute when we look at that. So that's just something to keep in mind. And so if you're trying to write a KQL query, you don't have this column, maybe you have a column by a different date time name, you can use that and just query, like craft the query to filter based off of that, or you can use something else, right, to do the filtering.
Yeah, I guess in many situations, this would be like a reference table, right? Which in its essence doesn't really have time generated, right? Because it's just a reference table like we have in watch lists in Sentinel as well. So this would be kind of that same use case. So
Exactly. Now, one of the other things here is that data is not living in the lake, right? We know that data is living inside of Databricks. So what if something changes with the columns in the table? As we mentioned, the schema is pretty important, right, for you to be able to see and craft the right query. So one thing that we've done for you is we've given you a refresh schema button. Now, hopefully in the future, sometime soon, that'll be automated for you. But at least for now, if something changes in that data source, you're going to want to click on that button. So if you've got permissions, right, to make a connection, you've got permissions to manage tables, you'll be able to do that here in table management seamlessly. So it's a one-click experience. And behind the scenes, what it's doing is it's using all of those service principal details that you filled in, and it's making that connection and doing all of that heavy lifting for you behind the scenes.
cool. So now I have my tables now present or visible in Sentinel, right? So what can I do with them?
So let's try running some KQL queries next. So if we switch over to Data Lake Exploration and go to KQL queries, not only can you run queries, you can of course create KQL jobs. You'll be able to run your Spark notebooks and your jobs inside of Notebook as well. All of those capabilities will exist, inclusive of even creating an MCP tool to reference federated data and running off of that. Now, the first thing that you want to do when you get to KQL queries is when we created that federated connection, that metadata was associated to our system table store. So you'll want to make sure that the system table store is loaded in your view for KQL queries. So now that I've done that, you can see here I've got a few different federated sources. All of them will show up under this new out-of-the-box grouping called federated tables. And then there will be a group for each connector type that you've actually used. So in our case, we've used all three. So you can see that there are categories listed for me for each one of them, and I can expand those and then view those tables that I've brought in. So let's go ahead and run a couple queries. So I've preloaded a few queries in this tab here. So you can see at the top here, we've got some HR logs that are sitting in ADLS. We're not able to move those logs, so we want to be able to reference them in our query. And to set a little bit of context, actually, before we even get started, what we're doing here is, let's say that you as an analyst have some alerts related to some abnormal sign-in activity. You've got a specific user that's showing up in your alerts. They're doing things like signing in after hours, maybe their behavior is not their normal baseline behavior, and this triggered an alert within your organization. So in our case, one thing that we want to do is we want to understand, let me just take a look at all of the risk across my org, and let me understand, are my employees active? Are they resigning? Are they terminated? This all will give me a lot of richness, right, in the investigation to understand if what I'm looking at, what level of risk, how abnormal really is the behavior that I'm seeing. So I want to pull in HR data for that to show me the status of my employees. I have some data that is owned by our team. Maybe we have a data science team. We've got production pipelines running against this data over in Databricks. For regional regulation reasons, I can't move this data. So here I want to bring in information about, hey, is any of that behavior I'm seeing related to any of the critical business of my organization? All right. So here we've got data from Databricks that we want to bring into our investigation. And we essentially want to also tie this in with those sign-in logs, which is where we saw the initial abnormal behavior.
That's super cool, right? Because you can basically join a table that is coming from a federated data source with a table that is in your data lake, in Sentinel data lake, basically.
Exactly. So here, when we've run this, we've got a list of several employees in our organization. And as we take a look at this list, we can see we've got that risk signal column showing up here. And we can see that at the top of this list, we have someone that's showing up with a really significantly high risk level here. So one of the next steps I might want to take is maybe I want to take a look at them a little bit more deeply, really understand what's happening with this user. Why am I seeing such a high risk count? And how can I learn a little bit more about that? So there's going to be a few ways you could do that, right? I could continue to run queries in Data Lake Explorer, or I could choose to say, maybe I want to switch over and try an agent out on this data. Now, one of the things that I mentioned is if you have MCP tools, and in our case, I have a few MCP tools that I've created already. I can show you what these look like. So if you take a look, one thing that I'll mention, I know we're working on documenting this, is whenever you're using a federated table or table that's in system tables in the MCP tool, you want to make sure that you're adding this workspace default dot in front of that. Default is the term that is being used to reference system tables, but make sure that you have that inside of the tool.
Got it. I didn't know that, so great tip.
Yeah. So here we've got this tool created. We have a few actually. So there's one here where I can show you, you can parameterize right inside of here. So you saw that we ran a query using just a basic look over the entire environment. But if you find someone suspicious, in this case, we saw Renata Hall showing up at the top. I may want to pass somebody from a result that I have into another tool. So I've done that here, right? I've created a tool that takes in a parameter. So I'm going to switch us over to VS Code, and let's take a look at invoking this MCP tool to get a look at what that might seem like. All right, so here I have agent loaded. In the upper right here, you'll see this toggle chat button. You can go ahead and click that. And once it's open, I already have an agent in my environment called Sentinel Investigator. And this agent was really just told a couple of simple instructions, right? Namely, when you're trying to do an investigation on risk, I'd like you to use the global fraud tools that I shared with you a minute ago. Use those first, right, when you're doing that investigation. So here, I'm just going to use a natural language query, and I'm just going to say, Sentinel Investigator, find the highest risk user in my environment. I want you to deeply investigate that user and return a clear, easy to understand summary. Highlight your key findings with visual icons and provide the recommended next steps. So let's see what happens when we run this. Okay, so our MCP tools have finished running, and let's take a quick look here. So we did a really quick natural language query, and it gave a really amazing report out of that. So we can clearly see Renata Hall is being flagged. She's resigning. Her termination is actually effective tomorrow. And we can see that the risk score is 8 times higher than anybody else. And we get a clear view. What are the key findings? We can see the activity timeline. So here we can see that it's not a single spike. This is something that's been trending over time. We can see that quite recently, last month, they pushed a lot of data out. So after this, they made that determination they wanted to resign and submitted that. And then we get that investigation summary and also those recommended next steps that we asked for. So Javier, this is just a really quick overview of some of the things that you can do with federated data that make it look and feel like it's part of that native data lake, but it's actually sitting outside of the lake.
Pretty good, Amy. Thank you so much. A few questions that I have for you. So first of all, something that every customer is going to ask about: how do we pay for federated query tables and so on?
Federated data is going to be charged in the same way that we charge for you running analytics against a data lake. So when you're running a notebook, you'll have your advanced insights meter that's running. When you're running KQL, you'll have that KQL meters, right, that are running for that compute and for that query.
Perfect. The same meters that we have before apply also to federated tables. Cool. And one other question that I also heard, in terms of performance, what can customers expect for federated tables? Do they get limited by the source platform where the data is stored, or is there some other kind of compute involved?
So performance-wise, it's going to be similar to the performance you would see with data lake. And something to keep in mind is there could be factors that affect the performance. As you mentioned, this data is sitting in an external source. Keep in mind even your connectivity, right? There could be situations where your connectivity itself is going to affect, the time frame it's going to take you to pull data back and to analyze that.
And one last question. I'm assuming that federated tables are read-only, right? There's no way for us to write into those tables that are somewhere else, right?
Yeah, that's a great call out. So for this feature, it is one direction, right? So Sentinel is able to reach out to query these tables in place, and there's no writing back to the source as well.
Perfect. So, Amy, thank you so much. Tell us a little bit of what's next. What's coming next into the federation in Sentinel Data Lake?
More sources is what we're looking for and just better overall experience. So we're really excited and looking forward to hearing feedback from customers, from partners to see what is working well, what they would like more of, how we can make things simpler. So really the next step for us is to improve what we have and give you more options to connect to.
Perfect. Amy, thank you so much again for coming to the show and talking to us about federation in Sentinel Data Lake. And thank you all for watching. See you next time.